We are Gucci Poochie. So, oh, wait a minute. Oh, I did a boo-boo. Hold up. Hold up. This is session two, part one. I'm gonna split these. Okay, so what am I doing? Why am I here? What's up with student stuff? I do tutoring and teaching, but in the case of like any subject you basically want. Uh, Programming, mathematics, basic algebra, college algebra, calculus, trigonometry, programming C++, JavaScript, PHP, Python, artificial intelligence, machine learning algorithms, data sorting, database management, all of it. Um, so I'm focusing here on math though, for now. Most of my students are mathematics students between the ages of 9 to 18 at the moment. But overall, in the lifetime of my 15 years of teaching, I've had students from probably the earliest age 8, 7 to about, man, 60? But this is including programming. I had a very old individual, God bless his soul, um, wanting to learn how to program or make video games. We went through a great process, but turns out there was a big speed bump in his way. Skype and everything computer related. So he wanted to make programs and games, but he had issues with the right click and the control C, control V, basically computer usage. So while he was technically a student in my game design class, I had to move him down into more of a, well, computer admin or user class base. But I have taught all ages essentially, and currently we're focusing on mathematics. All my students currently are in math. Everything from basic calculations, basic mathematics, uh, intro to algebra, advanced algebra, AP calculus, and everything in between. Now, I got my coffee. Yes, I got my coffee. Just making sure everything's working. I'll see if I'll wait a little bit for anyone to join in. I'm gonna set up some of my little watch places so I can make sure I'm watching all the chats for anyone to message me, give me any questions. I am taking live questions, so if anyone does have any mathematical questions, feel free to drop them in chat. Comment them also, because if you comment them, at least, okay, if we're in session, I'm doing a problem, post it in chat. Just send me a message. Hey, I need to understand how to do this. And I'll go ahead and work it out for you and show you and detail it out. And essentially, we're going to have a tutoring session, however, through chat. Um, if I'm currently in a problem and you send me the chat, I will go to your chat and I will do that problem, but it might take me some time to finish the current one because I want to make sure I kind of complete thoughts, right? Make sure everything's going up smoothly. What? Is this right? So I'm going to slowly wake up. This isn't right. Hold on. What? This should be right, but something's not updating, right? So feel free, go crazy in chat, give me some messages, let me know what you think. So part two, session one, it should be part one, session two, but okay, that's fine too. Two. I'm trying to organize all the sessions we're going through. The first session was like a couple of days ago, maybe 3 or 4 days ago. Did that update? I don't know if it updated. Okay, it did. Okay, 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 good. So now we're in session two. We're going to continue down the line of content, and this is basically my OneNote. If you haven't seen it before, here it is. These are my current students in Stigme Learning. It's a website. It's pretty cool. It's not mine. It is I basically contract as a tutor for them. We deal with a lot of students that have troubles, known troubles with mathematics, whether it's learning impediments like ADHD, OCD, dyslexia. I tend to have very unique students and very interesting sessions. So that is Stigme Learning. If you look it up, you'll find more details. But overall, let me see my old students. Let's go through some old students. We've got students specifically, then by subject. Let's do some by subjects. Okay, I do need to organize some of these a little bit more. Chem equation, stats probability, logic set, chemistry, linear algebra. I do science and chemistry and physics as well. I like math mostly. So, but I do definitely work with science-based, basically anything STEM related. So, in the end, STEM is my forte. Anything STEM related from programming to science to mathematics, technology. T? Is that what T for? T is technology, right? So basically, even computer stuff, Linux, Windows, Mac, Android, whether it's managing, administrating, or hacking, quote unquote, rooting, unlocking the potential of your systems. I do basically everything, which is pretty intense. So that's not an understatement. This is me working in this field of I have students that need help somewhere in some subject for the last 15 years. And I've put myself to learn those things. If I don't remember them, if they're too vague, I will go through and learn and go through the whole session before the student happens so that when the session happens, I can properly introduce the information. Oh, actually, I do want to go over one thing. And it's the thing that basically everyone struggles with in mathematics. And that's called factoring. Not that. That. Oh, even this. That's a goodie. That's a goodie. Solving for a specific variable when the whole problem has a bunch of variables. So let me get my AI give me some problems to solve. Like, if you guys don't give me any problems to solve, I'm gonna ask an AI to give me some problems to solve. So probably better if you guys do it because then it's more relative. Otherwise, the AI will be the guide here. All right. The subject's factoring. So, give me 5 problems in algebra factoring, going from easiest slash early algebra learning to more advanced, later tricky slash more advanced slash tricky problems. Boom. I use Grok personally. It's not bad. Not bad at all. So here's the evolution. Actually, here we go. This is nice. The evolution of factoring. I'm gonna maybe make a new page. Boom. Make subpage. Evolution of factoring. So factoring comes in many forms. Depends on essentially what you're given. I like to think of factoring as puzzle solving. Because sometimes, well, there's a particular method you can take that basically goes through the whole process without having to do too much puzzle solving. But there are cases where a problem's easy enough to solve if you can quickly solve a specific combination of numbers. So the first case scenario is, where do we begin? First problem, thinking about a factor or factoring certain values. So basic monomial. And this is the case of basically having this um, insight into the numbers you're looking at, right? Because we see 12x to the third. That's fair. But there's caveats to that because we can split these values apart in many different pieces. The kind of default that I always go to, why isn't it? Go to the right, dude. There we go. The default I always go to is take any number in space, call it the number 5. You'll find numbers in front of it. These are mathematical instincts that exist, but don't necessarily have to be written down every single time. Something like what's in front of a 5? It's a times 1. That's a little bit too thick. A thick boy over here. Then what kind of 5 or 1 would it be? It would be a positive. This is by default. We know the 5 in its own just exists in space, but there are values around 5 that can be uh, brought to light if necessary. Sometimes when we're trying to combine fractions, like 5 plus 2 over 3, first thing we have to remember is what is underneath 5? Well, it's the number 1. So we enter this sort of mathematical instinct of what are all the particular numbers around any given number in space. Because in this case, we put this over 1, we get the common denominator, we bring out, technically, the process isn't it, they don't show this every time, but they take another 1, and then they change that 1 to a 3 over 3, because that's still 1. And then they say, hey, multiply the top by 3 and the bottom by 3, but in reality, you're just splitting a 1 and making it a fraction. And that's going to give you 15 over 3 plus 2 over 3, which basically now gives us the common denominator and gives us our final addition. Excuse me. Still waking up and coffee and the trying to do this first so I can play some StarCraft later. So these are the techniques where we do use certain values that pop up out of nowhere. It's useful to know there is a 1 underneath our fraction. And it's also useful to know there is a 1 in the front, both multiplying or using our division. So multiplication and division are a very good sort of interaction here. Then there's another one, the plus 0. A little bit trickier. Because when we think of a plus 0, it basically can also be split into multiple things as long as it reverses back to a 0. So thinking of the possibilities, well, oh, where am I at? Oh, jeez. I didn't. Oh, I'm retarded. Oh, I'm still waking up, y'all. I'm writing down stuff on this, but it's not popping up because I had a stupid window in the way. So, excuse the retardation. In fact, I probably want to do. I'm gonna do this real quick so I don't get do that again. Come on. What? Oh wait, no, that's not right. Come on, move it over. There we go. All right, that's my bad. I made a boo boo. So let me redo that again. Going to the factoring process here, and I do see everything's fine now. We're looking at taking this 12x to the third power and expanding it, finding what is inside of this set of numbers and variables. The mentality we have here is that we're so used to seeing numbers condensed into one, we don't observe them as smaller pieces. So, one way we can exit this mentality is using the mathematical instinct of observing any number in mid-space and asking that number, hey, what is around this particular number? So I'm kind of redoing everything I did earlier because I wasn't showing any of this. Make sure you let me know if you don't see the right stuff. Why isn't it? Okay, it is showing finally. All right, I have to become alert. So from here, we can ask a couple of questions like what's in front of 5? Well, we can do a times 1. That doesn't change anything there. This is also the key for any prime number. When we're looking for primes, we always look for specific numbers that are just multiplied by 1. And that's qualification of a prime. If there's any other options, then it's not considered technically a prime. But in this case, we're observing the 1 in the front. Then we can ask, well, is there anything else in the front? Yes, there is a positive association. In fact, always associate signs on the left side of the number attached to the right. What? Is that a highlighted arrow? So any sign to a number will exist on the left of that number, and it is always attached to the right. Then we can ask further questions like what is around 5 in another way? Well, if you've done fraction addition with any whole number, then you're essentially taking a look at, all right, I need to add fraction with a fraction, but if I have a whole number, my professor, my teacher, whoever taught me to put it over 1. Why? Well, because 5 divided by 1 is still 5. So keep in mind that we are making these numbers manifest. We're exposing them, but they don't actually change the value of that 5. So keeping this sort of mathematical mentality, we can start to see values in different ways. And what will we do? Well, if 5 over 1 plus 3 over 2, we make a 1 appear, like a Pokemon in the front, a wild 1 appears. But then we can also adjust that 1 to a equivalent fraction, something that's the same, but looks different, like 2 over 2. Why would we choose 2? We can do 3 over 3, we can do 5 over 5, we can do 10 over 10, anything that equals 1 in the end. Well, we chose that too because we're trying to get a common denominator. So this is how we can adjust certain um, equations, certain numbers, and this is what happens when like a student is watching a teacher on the board, and when the teacher skips a bunch of steps, and then the student's like, "Where did that number come from? What happened there? Where'd you get that 2? Where'd you get the over 5?" Like all of those pieces, if those were always a question, this is what's missing from your mathematical grammar. This is grammar. In the sense of the previous session, I kind of introduced mathematics as a language, a spoken language of data and information. And it comes in two flavors. You got vocabulary and you got grammar. Vocabulary really just depends on what class you have. Geometry, that has a specific set of vocabulary. Squares, triangles, circles, cylinders, yada yada. Trigonometry, sine, cosine, unit circle, etc. Calculus, derivatives, domain and range of complex functions, etc. Right? So those are just vocabulary words that you can basically put on a piece of paper, on a flashcard, and basically force feed them to yourself, you know, to get them through. But the second piece to the resistance is grammar, which is the biggest piece and which 90% of students have an issue with. So we're looking at the particular piece in mathematics that the huge majority of students either have a vague pattern, solving process where they know they put a one underneath, but they don't know why they put that one underneath, but they've been told to do it, so they just keep following the process. With that in mind, we're essentially considering, yeah, you can follow them blindly, but that limits your ability and your approach to creatively solve mathematical equations. Once you understand why that one is there, because there's these invisible values around any number in any given space, including the one at the bottom, and we can choose to make it pop up if we want to, especially in the case of fractional addition. Knowing these kind of grammatical processes gives us the ability to put together a strategy for puzzle solving. And that's all math is. Algebra is just puzzle solving. So considering that factor, we have some other things we can work out. So I'm just going to finish this because I started it. 2 times 5 is 10. 2 times 1 is 2 plus 3 over 2 equals 13 over 2. And thus we have combined two fractions together. So again, using the tools that would best benefit us, we take those into account. All right. Then there's another piece that's invisible. And this is the case where most of the time it makes sense, but it doesn't make sense. And this is where stuff comes out of nowhere and students will go back to where did you get that 2? How did that 5 come out of nowhere? This is what happened in some form, but if a teacher skips steps, it's hard to see what happened. What they would do if a 2 pops up or a 5 pops up, they would say, hey, if I want an extra 5 somewhere, I'm going to split the 0 into a positive 5 and a negative 5. Through addition, they become 0. So we can reverse that addition, and voila, magical math, Wingardium Leviosa, two different 5s pop up out of nowhere. So this is definitely a factor here in mathematics. We can take numbers out of nowhere as long as they reduce back to the original. And what is the original? Well, it's that 5, just the 5 on its own. So in the form that all of this exists, but we don't have to think about it, we can basically simplify it back down to 5 if we want to. And that's the balancing of equations. So with that mentality in mind, there's also this plus or minus of a 0, but there's also this multiplication of a number that we can factor apart. This is super useful, like the biggest tool in mathematics that you basically use to find and puzzle solve with. We take a 12. What numbers make up 12 when we multiply? 6 and 2, 4 and 3, both of those. So technically, we can choose either one. If I start with 6 and 2, I can now look at 6 and be like, wait, but that also has a factor inside too. Some multiplied numbers that make 6. Okay, that's 3 and 2. But hey, wasn't 4 and 3 a part of our possibilities too? Oh yeah, because if we take 3 times 2 times 2, that's 4. There's 4 times 3, and there's 6 times 2. So what we basically do is take apart numbers to their base components. I like to call it the numbers DNA. A 12 is always going to have these particular multipliers. And we can say that the DNA, quote unquote, would be 2 times 2 times 3. In real mathematical terms, that's a factor of 12, all the pieces that make up 12 in multiplication, and no matter what order you multiply in. But if you use that little trick to say, hey, I need to find some different multiples, that's what factoring comes in very, very strongly, then you're going to take 2 times 2 and test for the 4 and 3 for a specific reason. Maybe you need to figure out if 6 times 2 works for something or if 4 times 3 works for something. But if you go down to the base components, you can basically get every single multiplier that gives you 12, or combination of multiplication that gives you 12. So that's the basic factoring for a number, a digit. Then we have a variable. Well, we have to remember that a exponent basically includes this sort of multiplying chain of the same thing. That goes back to taking our 2 plus 2 plus 2 plus 2 plus 2, realizing mathematicians are lazy. And if we have some problem like this that gives us 10, another way to write this without writing so much is two fives in multiplication. So there's a shorthand for a bunch of additions that copy and paste themselves over and over. That shorthand for addition is multiplication. A copy of addition can be put into multiplication. Then you might have 3 times 3 times 3 times 3. 3 times 3, 9, and 9, 81. Well, that would be another copy and paste, but this time we're not using addition like we did before to go to multiplication, this sort of transition of laziness to write less. We're actually going from addition, or sorry, from multiplication to a power, exponent. We say 3 to the fourth power. That would be equivalent to 3 times 3 times 3 times 3. This doesn't, of course, stop for just numbers. It continues on for any particular set of copy and pastes. This also works for x to the third power. This is basically just x times x times x. End of story. That's it. Nothing too complicated there. So while variables will format themselves in a line of variables, if we have x to the third is x times x times x, numbers tend to be a bit more explicit about what they are, the actual values that make up the numbers. While variables will be more implicit, and because we can plug any number inside of x, it basically becomes just a pattern that we're identifying. And so factored form for a basic monomial is this. This is the beginning. This is what we need to understand from the very, very, very first case scenario. And this is the first thing you get introduced with factoring. Then we consider GCF, greatest common factor. Watch the words. It still has to do with factoring. The way we take apart numbers in multiplication to observe them in different ways, like the 12 being 2 times 2 times 3, it's the form of multiplication explosion, if you will. A explode, like if you take like an iPhone and you can visualize all the parts inside, that would be the term of exploding that iPhone. See, not like a bomb explosion, but like exploding the components, seeing the screen, seeing the back plate, seeing the motherboard inside, seeing where the camera is, seeing where all the little battery parts are. And that would be a case for how we explode objects into its base components. And that's what happened here. In GCF type factoring, we identify those same key points. I normally approach this in the very long form just so you can see what we do from the get-go, but you don't have to approach this every single time you want to factor stuff. We do the same concept. We take 2 times 3 for 6, x times x for the variables, 3 times 3 times x for the second part. So we're basically taking monomial factoring, basic monomial factoring, and doing it twice for two sets of values. Greatest common then becomes, hey, we're identifying what they have in common. That's it. So use those words to your advantage. Don't let vocabulary words disenfranchise you. They do try to be as direct as possible, even though sometimes it feels obfuscated. We take the factors of each term monomially, and then we find the commons. What we do then for that GCF process is we take that value out. So we took 3x from both of them. And in a longer process, I suppose, you can say that you are dividing by a 3x here and dividing by a 3x here. Division, we know, then cancels these values out, and that's what brings it to the front. So when you divide out, you're basically extracting to the front of both of them. Voila, right there. And then the remaining non-crossed out stuff stays inside. And that's it. GCF is now more of a way to simplify these problems to a different perspective so that we can take a look at the actual things they have in common, and that's the opposite of distribution, which distribution would basically be taking that 3x and putting it back in the parenthesis, multiplying. But this is a great way to kind of organize your numbers with the commons on the outside and the unique on the inside. Okay, that's a weird circle. Come on, backwards. Why is it doing that? Stop filling in my writing for me. Thank you. They've changed the OneNote and it's become a little bit of a annoying hassle here. So this basically separates our values into unique and common splits, organization, adjustments, observations, analysis, whichever way you want to look at it. But there's a reason to do this, and you'll see it in the future when we go through some of the more complicated factoring. Now, I did it in the kind of more expanded form, but in reality, if I had something else like, and I wanted to figure out what factors from them, what's a common factor, greatest common factor. Well, I can think of the fact that there's a 4 inside of 16, that's 4 times 4. I don't really have to split the 4 in the front, and I can say I'm going to take one 4 from here, another 4 from here. That's the only thing that's common between them. So I'll write it in the front and keep the rest inside. So you can skip the actual extra writing, but it's a case of like, are you used to it enough to basically see it in your head and then skip it? Because sometimes, teachers want to see your work because they want to make sure you're approaching it with the correct process. Then you would be most likely be doing it this way, even though it's a longer form, because you're essentially trying to explain the process visually. So there will always be a long form and a short form in any subject within the mathematical space. The reason for that is because once you're doing long form plenty of times, you become comfortable with the process and you start just doing it in short form so you can save time. This is kind of the reason I hate test taking, because that's the motivation behind short form. You only have X amount of time to do a test, so do it as fast as you can. Good luck, bye. That kind of beats the purpose of continuously being elaborate in our explanations. If we didn't have tests, we'd all probably be doing everything in long form because we'd have as much time as we need to go over it, to put all the pieces together and work it out as necessary. But in tests, you'll be doing it in short form. When do you do long form? When you're learning it. And eventually you progress from the learning process to the test process, and you just do everything in short form. Unfortunately, teachers are stuck in short form because they see everything happening and they assume you're seeing things happen in the same way. So they're like, oh, they know how this works. Let me just show them the process. And then there's like two, three people that are like, oh, yeah, I get it. And then there's like 20 people like, where did that five come from? Where did that exponent where did the exponent go? Why is there a radical now? So like that's why I don't like the short form until we go through the long form in a nice and clean manner. But there's your GC factor, GCFs, greatest common factor, and that would be the level 2. So up here, we had level 1 factoring. Like this is like you spawn into factoring world and now you're in the tutorial learning what a factor is. Level 2 factor, you met the checkpoint boss where he was kind of difficult at first, but you got your health packs, you got all your dungeon gear, and you were able to get through that particular boss. Now we go to the actual level boss, uh, what is it? The chapter boss or something of the format. The area boss, right? Because an area might have different pieces and different mini bosses. So we got the mini boss out of the way. Now we got quadratic factoring. You can call it different things, factoring a quadratic trinomial, and then there's like different variances of it depending on what kind of equation you get. But this would be like the first version. So this is level 3 boss, first, um, what's the word? First evolution. This is when you first meet the boss and he's like, "Oh, I'm pretty difficult and powerful, but you have a pretty decent chance as long as you follow the general rules, you can beat me." But then when you beat him, he becomes another more advanced boss, and now he's got Gatling guns and can fly and can have an invisible shield for 5 seconds. And now you have to strategize when to attack, when to dodge, when to shoot, when to heal. But the first case here, this is a level 3 boss, area boss, we can call it actually. And he's kind of the level 3 difficulty. Quadratics. This is basically where a lot of students get stumped. And the reason we go through the level 1 and level 2 is because we need them to guide us through level 3. So, level 1, basic monomial factoring. Level 2, GCF factoring. Level 3, the boss they're about to fight. So we'll start with the first evolution of this boss, which is a simple factor. Nothing too crazy here. We're essentially trying to find some puzzle solving mythologies. There is a sure way to go about it, and then there's a guessing way to go about it. We'll go over both. The guessing way is to consider that we came from a group of parentheses. The foiling method is very necessary here from the distributing strategy. You got to distribute or combine every combination of stuff in order to find a final piece of the whole. So you're basically just combining every possible combination. Remember that if there is no sign in between or no operation between values, it's always multiplication. So AC is the same as A times C. AD is the same as A times D, etc., etc. So we come from this and we have to logically go in the reverse. We have to say, hey, A and C need to be x squared. How can I do that? Well, that means that we need to factor that into pieces. Therefore, it's going to be x times x. So the guessing mentality is x in the first parenthesis, x in the second parenthesis. The guessing slash puzzle solving mentality. Then we look at the last case, the 6. And we say, hey, I need to have two numbers to give me a 6. Okay, what possibilities do I have? I have 2 times 3, and then 1 times 6. That's messy. Let me reorganize that a little bit. 2 times 3, and 1 times 6. But we can't just kind of rush to use one of them because there's another requirement. It's the middle. It is the AD plus BC. Naturally, those are going to be a mixture of x's. You're going to have some x value plus or minus another x value. And what they need to combine is to be the middle, the 5. I can see people coming in and dropping out real quick because factoring ain't a joke. I know, I know. Very exciting. This is the problem with being a teacher. Even if you're elaborate and attempt to be entertaining, you're still doing mathematics, and people in math are just gonna drop out real quick. I mean, this is the society we live in with the shorts. If I can't explain something in 5 seconds, everyone starts looking at the fly or butterfly in the room. So, it's probably a better video to be watched when you watch it on your own time when it's done streaming. Potentially not a good live type video. So our combination of either 1 and 6 or 2 and 3 have to essentially add or subtract to get the middle. Well, if you've done the math already, you just try it out. 1 plus 6 is 7. 1 minus 6 is 5. Interestingly enough, we also have a 2 plus 2 times 3 is added. You can get a 5 here as well. And then you can get a subtraction of 1. So these little jumpy signs here are just us combining 2 and 3 through addition to get 5. Here we combine 2 and 3 through subtraction to get 1. Here we combine 1 and 6 through addition to get 7. And here we combine 1 and 6 with subtraction to get 5. So now we're kind of at a standstill. We have two possibilities here. This is actually a much more difficult than expected one. We either have 2 times 3 added gives us the 5, or we have 1 times 6 subtracted gives us a 5 also. So we kind of have to consider the signs now. We have an addition and a subtraction. But through the foiling process, we're essentially going to need a positive 6, this guy right here. So if we have a subtraction, we would have to include that negative in one of these values, like the negative 6, for instance. So when we go backwards and try to check it, wait a minute, 1 times negative 6 is not a positive 6. We need it to match completely. So we can disqualify the 1 and the 6 because if it was a negative 6, then it would have worked. If it was the minus 6 at the end, we would have had no problem there. But because we have a positive 6, we can't use anything with a negative in it, which was a negative 6. So the better choice then would be plus 2 and plus 3. So that would mean we put a plus 2 here and a plus 3 here. This will be the case. So it may have been a bit difficult to follow, but now when we have actual numbers and we approach foiling, we'll see that we're going to do this right here. We're going to approach the foiling process with these values, and we're going to end up with the original problem. So we have to essentially use foiling, the patterns of what combines with what in the foiling process. If you're not familiar with foiling, it is the first, outer, inner, last case when you're multiplying two parentheses. I don't like FOIL. I just refer FOIL to the particular thing we're doing because first, outer, inner, last, yeah, well, prospectively, we can kind of conclude a lot of things about which is first, which is last. But in reality, first is this. So x times x is our first, which is x squared. Outer is x times 3, which is 3x. Inner, 2 times x, which is 2x. And finally, last is 2 times 3, which is 6. Positive for this. Basically, they're all positive. We don't have any negatives, so we wouldn't expect any negatives to pop out. Then we combine them to a 5x plus 6x squared plus. I don't like this method. I don't like guessing. I don't like any method that I have to do this and have to figure out the combination of this and that and how to put it together with this. So I showed this method because this is the number one method shown in public education. What is the God mode of this method? It's called AC and then group factor. You don't have to memorize processes. You don't have to understand the AC method. You just need to understand everything I've taught you up to this point when it comes to level 1 and level 2. What we just did with the foiling process didn't even include any real justification of level 1 and level 2. And that's where I kind of have my grievances with public education because they try to use these cute little acronyms and then confuse the crap out of everyone when they try to explain them. So, how do you actually do this with less explanation? AC. We consider that we know if you're at this point, it's A, B, and C, the numbers in front of the variables, A, B, and C. So we take the A and the C, which is the 1, the invisible 1, remember? Instincts, invisible 1 times the 6, and we have the number 6. We still do our factoring, our prime factoring to 2 times 3, or 1 times 6. We still have to apply that little logical conclusion that we need a positive set of numbers, so trying to subtract 1 and 6 won't work because when we multiply a negative in there, like 1 plus negative 6 would give us, or even backwards, would give us 5. I can actually erase this extra plus here. But negative 1 times 6 would actually give us a negative 6, which conflicts with the original positive value. So we cannot use that. But if we just straight up add 2 and 3, then that's good. We can find our 5 that we're seeking, the middle, the B. So what do we do from here? We take that fact, we take our little instinctive factors of numbers or uh, our numerical gymnastics, if you will, and we take 5x and split it into 2x plus 3x. That's it. No guesswork. We do a group factoring now. So up to this point was the AC method for the middle. Then we do group factoring, which means we basically split this into two terms on the left, two terms on the right, and we factor. The left side has an x in common. The right side has a 3 in common. Same thing like level 2 factoring, GCF, right? G or group factoring involves the GCF, greatest common factor in the group factor. Oh, that's a 2. So when we identify the pieces that we like and we put them to the front and the pieces that they have in common that we like and put them to the front, then there's a bigger piece we have to be aware of. Not only individual highlights of X, but also groups can be common as well. So we take that sucker out to the front. And then we have some remaining pieces left. And we're done. That's it. You basically have 4 lines of code, if you will. One, two, three. 3 movements, 3 adjustments, and you got yourself the factor. No guesswork, no what combines with what, no remembering how to FOIL works, no, basically it's just a headache. No checking yourself too, because this method you would have to check yourself so you know that you got the right combination, just in case some mental math got a little bit fuzzy after doing all of this crap all the way down. That's why I prefer group factoring. It's much straightforward. And guess what? This works for every one of these versions of the boss. So it's like having the ultimate sword and you hit the boss with one strike on the first incarnation, he dies. We're done. Then he comes back, you hit him with the same sword, he dies. It's like having the ultimate weapon. It's not like you're gonna have to constantly change the way you do the problem if you just do the AC to the group factoring process. That solves every single group of quadratic factors, quadratic functions. So this brings us to the next one. In this case, our A was 1. So there's like this other strategy for when A is not equal to 1. But as long as we maintain our group factor mentality, that doesn't matter for us. So, boss incarnation, version 2. We have 6x squared plus 11x minus 10. Man, the first stream I had with the office was pretty, my office hours in the math was pretty good. It was pretty good. I have a good set of people coming through, taking a look, see, enjoying the easy math. Oh man, but this one's gonna be a toughie. I don't know if a lot of people are gonna watch this one, because it just ain't it, man. It is not what people like, which is fine. It'll exist on the internet for anyone that wants to see it and help out on their journey through these. So let's take a breather. Ooh, consider the next steps. Ah. And probably we're at the fourth set of 5 problems. We'll do with the 4. The sum of cubes goes a little too far. We'll stick with quadratic for now. So, okay. It is also a case for where you can guess. You can do this too. You can consider the foiling method. You can be like, oh, this is 2x, 3x. I'm guessing then 2 times something plus 3 times something. That's a 10, so maybe it's 2 times 10 and 3 times 2. Uh, so that's 6 plus 10, 11. Wow, I found it. And then I need a negative. Oh, but then that'll be subtraction. Hmm. I might need something else. I may need to flip these around. So this is the guess method without all the extra writing. If you have no idea what I'm doing, then essentially you're going to be doing the group factoring method. So then you have 5 and 2. This is going to be 4x. This is going to be 15x. We need a subtraction, but we need a positive 11. So the bigger number 15 is going to be positive. The smaller number 2 is going to be negative, and 5 times negative 2 is negative 10, and 15x minus 4x is indeed 11x. There, I factored it. I did the guess method. But if you're looking at this and said, what the hell did you just do? That's kind of the problem, right? You have to be used to it. You have to do it a lot of times, and you have to really know what you're looking for in order to solve this. So what if you don't want to, or you want something that actually works as a step by step? So this is the puzzle solving method where some students that are logical or that are creative, I think. Potentially the creative students can do this because they can see these things move around in their head and they can combine things. So the creative students can essentially look at this and be like, all right, I see what you're doing. I understand foiling. I'm applying the foiling method, which is this and this and this and this combination, and they're doing that in their head. And I need to match that everything gets to the same point. Great. But what if you're logical? What if you need a step by step? That's where group factoring comes in. AC method first. That's 6 times 10. Obviously, if I add or subtract 6 and 10, I either get 16 or a 4. Neither one is an 11. So that's our always considered check. This has to match with one of those. But none of them do, so we discard it. Then we think, all right, put together 6 and 10, that's 60. What other numbers can combine to give us 60? 30 and 2, but that's going to be weird. 30 and 2, I had a brain fart, plus, minus, well, that's a 32, or a 28. That doesn't work because neither of those are 11. What about 15 and 4? Because really what you can do is guess 15 and 4, or you can take this into your typical factor tree, take 60 and say, all right, we know it's 6 times 10, then this is 2 times 3, and this is 5 times 2. Well, what if I combine my 2 and 2 to 4, and my 3 and 5 to 15? Then you can also discover those values this way. Remember, because the DNA, no matter what way you combine them, you're going to get the values that you're looking for. And if I add those together, I get 19. But if I subtract those together, I get 11. Super. I need to get 11. So what do? I need to subtract to get a positive. I make the positive 15 here. So I basically now split 11 into two numbers that still equal 11, which is 15 minus 4. They make 11 when you combine them. I drop down the 10 to the left, right, the 6x squared to the left. No guessing about what's, how, and where. You just follow this process. It doesn't matter which side you put them to. They'll still work out. But I like to put the bigger number on the left and the smaller number on the right. So 15 is on the left and negative 4 is on the right. Then we do our GCF. So we completed step 1, AC, to find the numbers we need. Now we do group factoring. We put these in groups and we start taking stuff they have in common. So 6x squared plus 15x, well, that's a 2 and a 3 in the 6, 3 and a 5 in the 15. 3. I said 3 twice, so that can come out. There's 2 x's in the first and 1 x in the second. So I have an x. We divide them out if you want to visualize it that way. 3 divided by 6 is 2, x divided by x is, or x squared divided by x is 2x. 15 divided by 3 is 5. X divided by x cancels, so we don't write anything. Cool. Next step, right side, do the same thing. We push the negative, we attach the negative with that negative 4, with the 4, so we want to basically push it with it. And now we can take out a negative from both of those. And we can take a 2 out from both of those. So we do a negative 2, negative 2. Negative 4 divided by negative 2, 2. X left over. Negative and negative positive, 10 divided by 2, 5. Well, looky that. We have another grouping that fell into place nicely. So then that comes out to the front as 2x plus 5. And 3x and negative 2 sits right next to them. And boom, I can either guess it or I can group factor. So guessing requires a lot of mental thought, but it can be shorter if you've done it plenty of times and you practiced it, the puzzle solving format. Or the logical student wants a list, list of steps. That's the important factor here. A logical student wants to see, how do I do this? Give me step 1, give me step 2, give me step 3. That's just how the left side of the brain works. The creative student's like, oh, I can see how this relates to that. I can picture it in my head. And most of the creative solving factoring for this is going to be in the mind. I'm going to draw a brain. So all of this is done within the brain. Is that a good brain? I don't know. But everyone's different. And this is the problem with the public school system is they don't understand that there are two ways that people think based on, and it's not like black and white, right? It's not too super creative or super logic. There's always this sort of balance between you're either 50-50, some of you are 50-50, you kind of half understand both. Some of you are super 100% creative and you're like, yeah, I've seen foil before and I can see how you did these processes without all the extra writing. And then others are just straight up logic and they need to have everything organized and scheduled and in a step-by-step process. So you can do it step by step for the logical individuals, or you can do it creatively as a puzzle solving exercise. It all depends on what kind of student you are. And that's the important kind of finale here I want to go for. Understand yourself so you know what kind of methods you can approach. Understanding yourself is the first step to knowing how and what you can do to better yourself. And I'm not just talking about math. This is a life lesson. Understand yourself, know your weaknesses, and grind on those weaknesses so they become strengths. Don't let them go. Don't let them just exist because at some point in life, life is going to be like, hey, did you better yourself? Here's a test. And I'm not talking about a school test. I'm talking about you potentially losing money on something that you should have basically understood was a losing money situation. You don't want to be that guy that's going in debt for a motorcycle or trying to play the lotto because your buddy got $1,000 once 5 years ago and you've been doing it for 5 years and you've probably given them more than $1,000 by now. Better yourself so life doesn't trap you because life traps those that cannot unstick themselves, that cannot see the trap. If you don't understand how a trap works, you're not going to see the trap and you're going to fall into the trap and society's going to drag you along for the ride. So, whether you care to do it or not, it's in your benefit to do so. And life will show you in the future that what you do now will determine the path you take. Doesn't have to be, oh, you got to do math for the job that you're going to do in the future. Do you know what you want to be? A programmer, a computer scientist, a mathematician, a accountant, a data analyst, a blah, 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 trading stocks? It doesn't matter what you're going to use the math for because life basically works math all the time. And you being more capable in that skill, that logical or creative or solution based troubleshooting, because both of these, they're just troubleshooting methods. Being creative or logical is just a way that people can troubleshoot. You either visualize your troubleshooting process or you figure out what's wrong in the process of logic. That's why an individual that's creative can give a company much more creative ideas on how to attract more customers or make a new game. But unfortunately, in the gaming environment, we have AAA titles that are run by a bunch of logical people that are stuck with lists. And those lists have been hijacked by the political social system. And they have to put DEI, body type 1, and all these bullcraps in between. So, whichever list you decide to go into, or whichever method you decide to do, everyone needs troubleshooting. And if you don't understand that troubleshooting process, someone's going to edit your list for you and make you do something that necessarily won't benefit you. That's called statistics, and that's called loans, debt, buy the dip, uh, all kinds of weird things that gambling, lottery, everything that basically is intended to trap those not aware of how they work and how they can logically think about whether it's feasible to do that or not, whether it's feasible to buy the dip here or not, whether it's feasible to buy a lottery ticket or not. We're already like armed with the survival skills of, hey, that's a shark in the water. My troubleshooting skill says nope, but we don't see that same instinct in mathematics because the reason why this stream is probably going to be super empty, and it has been empty up to this point, at least on the YouTube side. I haven't checked the other sides. The other one got me some subscribers and likers and had some people talking about it. Like, hey, yeah, that's the answer. That's cool. And like, yeah, we were talking and chit-chatting, but 6 views from 70. And this is just on general sense. I have 6 views on YouTube. The last one has 70. On Kick, empty. On Twitch, probably also empty because gaming is for Twitch. Yes, empty. No comments, no nothing. This is the reason why we need to enable ourselves to not let our boredom and our not caring for something affect the way our future is going to be. And I've digressed. Oh, if you watch it up to this point, I respect you for listening to an old man's rant. But this is a very important troubleshooting trick. There are two ways to understand how factoring works. And if you understand which one you are, then you're already probably ahead of like 80% of the people on the market, 80% of students in class, because they're too busy about what celebrity did what's the new TikTok hype, to actually care about their own self-development. So I respect you for staying to this point. And join me next time because I'm kind of done with this one. Factoring is an annoying one, so I'm gonna have to do another stream maybe today, maybe later, but I feel like doing some StarCraft, so I'm gonna go play some strategy games. And I'm gonna cut this here because factoring, maybe we'll try it again. But factoring is not a very fun subject, and people see the word factoring and then they run. And that's unfortunate, but that is how it is. I just hope that one day we all see this as a puzzle and not a burden. And then we'll truly be able to do a lot of factoring problems. Find all the ways we can do things and all the ways we can troubleshoot and take pieces and problems apart into smaller pieces and then move stuff over and be like, oh, I can do this first and that first. But until